sort of yay big. It's, you know, if you've got one of those soda bottles, like a big Sprite or Coke soda bottles, that's generally about 2 liters. Now, if on average you threw one of those, a bucket that was 1 liter, into the ocean and looked inside, on average you would have no fish. You would have about 10 copepods, which are zooplankton, 10,000 diatoms, 100,000 dinoflagellates, which are a eukaryotic phytoplankton, 1 million nanoflagellates, another eukaryotic small phytoplankton, and 100 million cyanobacteria. So those are the prokaryotic phytoplankton. So next time you go swimming in the ocean, you're literally surrounded by millions of these guys. They're highly, highly abundant out there. There we go. And to give you an idea of just how small they are, if you're looking at the phytoplankton, they generally range in size from about 0.1 micrometers to 1 millimeter. And that difference in size, so the magnitude of difference between the smallest phytoplankton, which is Prochlorococcus, and the largest phytoplankton, which is Trichodesmium, that magnitude or ratio of difference is the same difference in size between a fish and the island of Manhattan. So it's huge, the difference in size between these guys out there. And often, to look at the smallest, so the picoplankton and the nanoplankton, you have to use an electron microscope. And in 1 microliter of water, so the picture of this finger here has 1 microliter of water, that tiny little droplet. I hope it's coming through the Skype. But 1 tiny droplet of water can contain millions. So if you look at this picture, each of these green dots is a picoplankton. And the big dot right here is a nanoplankton. It's a nanoflagellate. So it's huge, the number of guys that are out there. So I wanted to ask you, if you look at the globe and you were to smash up all of the world's continents into one big supercontinent, the ocean would take up about a third. It takes up about a third of our total planet, whereas our planet is 2/3 ocean. So I wanted to ask you, given how abundant these phytoplankton are, but also considering that they're very small, how much oxygen do you guys think comes from phytoplankton in the ocean versus plants on land?
Does somebody want to answer? Someone said 2/3.
2/3 from phytoplankton or from land plants?
From phytoplankton.
Phytoplankton. It's a good guess, but it's about half and half. Half of our oxygen comes from land plants because generally they're much bigger, so they can produce a lot more oxygen than these very tiny phytoplankton. But on the other hand, phytoplankton are extremely abundant, and our world is mostly composed of oceans, so about half of our oxygen comes from land plants and half come from phytoplankton. Now, these phytoplankton are also extremely diverse. Do you guys know what the term diverse means in an ecological, biological context? Or diversity?
I'm getting yes and no's.
So,
diversity, you guys know what it is? All right.
Generally,
yes.
Just to summarize, it's the number of different things, right? So if you have more different species, that means that it's more diverse. There's greater diversity than when there's fewer species, a smaller number of different things. So if you were to go out in the ocean and, drag a phytoplankton net behind you, like a very small mesh net, and, rinse it out and look at what you found under a microscope, you would usually get these larger phytoplankton. But in one droplet of water, you can have, 20 to 50 different species depending on the time of the year. So each of these little pictures here are pictures of actual microscope slides and the different types of phytoplankton that you can see that are out in the ocean. Now, overall, there's sort of a big trend in the number of species or the diversity of phytoplankton. So when we're looking at bacteria or